see two people out here with their lifeline out. Good. Everyone at table 2 has their lifeline out. Everyone at table 7 has their lifeline out. Good. Everyone should have it out in about 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Are we good?
Yes.
Okay. Whole class, are we good?
Yes.
Okay. Raise your hand. Hands in the air. What do engineers and architects make? What do engineers and architects make? Yes.
Building.
They make buildings. Yes. Do engineers just make buildings? What else do they make? Yes. Models of buildings or whatever they build. Yes?
Cars.
Cars. What if I was a software engineer? What would I make?
Robot.
Computers. I would make the software that's on computers. What if I was an electrical engineer? What would I make? Raise your hand. Yes?
Lights.
The lights that light up this room. Okay. Today's kickoff question. Scale model. Say it with me in 3, 2, 1. Scale model.
Scale model.
Okay, scale model is not just any model of a building. It's actually directly proportional to the size of an actual building. So the question today, why do engineers and architects use scale models? You guys have 1 minute. If you're an architect or an engineer, why would you want to make a scale model? Good, I see everyone quietly writing. Think about the fact that it has to be in proportion. About 35 seconds. About 20 seconds left. Good, I see some people are already done. Finish up your thoughts. And raise your hand. Let me get some hands in the air. And what are some reasons why I would want to have a scale model before I build a building? Yes? To give me ideas? What kind of ideas? What do you mean? Building ideas? Anything else? Yes?
I said to get an idea of how their actual building will look like, and they use it as a blueprint.
Good. Does it take a long time to build a building?
Yes.
Yes. How long does it usually take? Like a year? 2 years? Okay. Before you invest that amount of time into something, you might want to know what it actually looks like.
Oh.
Why does it have to be to scale? Does anyone know that? Why would I want to build it to scale? Yes? You want to be in proportion. Does anyone want to live in a building that has 30-foot windows and a half-foot size door? No. Okay, so one thing you want to know, what materials do you need, right? Another thing you might want to know before you make your building is, you want to have a plan for the length and the height of the building, right? Number 3, does everyone have $1 million in their pocket?
No.
To build a building, okay. What if you want to, most engineers and architects, before they actually build a building, they need to go to rich people to give them money. These rich people need to be convinced. So if I just said, I'm an engineer, give me $1 million, are they going to listen?
No.
What do I need to show them? Scale model, good. I want to tell them, how much money do I exactly need? What is it going to look like? And number 4, buildings cost a lot of money. Here's an example of a scale model. This is a little town. What are these? Boats. What are these? What are these?
Cars.
Classic cars. Does anyone know what city this is?
New York.
This is New York City. This is a scale model of this actually famous area in New York City. And what is the thing about scale models as opposed to regular models? They're always in what?
Proportion.
Whole class.
Proportion.
They're always in proportion to the actual size of the building. They often have ratios that are recorded in whole class.
Inches.
Inches to what?
Feet.
What does this semicolon mean?
Inches over feet.
This means 2. So that every inch would be how many feet? 5 feet. If I said there's 10 guys in here and 22 girls, what's the ratio? It would be 10 to 22. Good. Okay. So we're going to do a little contest today. If you look at your desk, you have 2 rulers. You should have a house that I just made up. Here's the contest. The winner will get candy. You need to, I'm going to give you the scale in 1 second. It's going to be inches to feet. You need to measure the size of this house. Don't do it yet, get an advantage. Shh. You need to measure the size of this house, and it's all made of wood, so it burns down easily. It's all made of wood. You need to tell me how many feet of wood do I need to build this house. So what would you have to do that?
Measure.
You'd have to measure each side. Tell me how many inches. But what am I looking for? Not inches, what am I looking for? Feet. Okay, the first group done to tell me how many total feet gets the candy. You guys ready? 5, 4, 3, 2, 1, go. There's going to be some decimals in there. The ratio is 1 to 5. Please write that down on your paper. 1 inch is 5 feet. 1 inch is 5 feet. Good, I see everyone engaged at group 6. Good. Group 5 is almost done with the measurements. Remember, 1 inch is 5 feet in real life. You guys have about 3 minutes left. You guys have rules? All right. Here's a little key. Measure everything and then add it all together to get the total inches. So I already have your answer, right? Are you going to stick with that? 2/3? What do you think?
Isn't it 32? Yeah, 32.
120.
About 45 seconds, let's go. If you figure out the total amount of inches, what do you just times it by? I need a final answer in 30 seconds, yes? Okay.
123. Okay. Have it.
What's the total amount of feet I need? How many total feet do I need? I'll come back. I got yours. Okay, I need a final answer.
Well, they're gonna win because they don't.
Group 3. What's your final? Come back.
How did you get 33?
I need something. Okay, and then 3.5? Yeah. Okay, what's 3.5 plus 3.5? Okay, what'd you guys get for the sides? You should have got 4.5 plus 4.5 is what?
9.
What'd you get for the bottom of the house?
Yeah, but you said 1 inch is 5 plus.
How many total inches is it? What's 7 plus 9?
16.
16.
What's 16 plus 5?
21. No, you got it right. Dang.
If you know it's 21 inches and you know the ratio is 1 to 5, what times 1 gets me to 5? 5. Whatever you do to the top, do to D. What's 21 times 5?
That's 105. 5 got it right.
And the correct answer was 105 through 5. You guys did
Oh my
it.
God, thank you, Ronald.
Round of applause for group 5.
I know we had that.
There was decimals.
You guys had to say that.
Okay.
Oh, wait.
Okay, I'm looking to see who gets them out first. Who gets them out first? Who's prepared? Okay. Group 1 has them out. Group 6 has them out. And we need a whiteboard. Can you pick that up and give it to her? Do you guys want to do that again?
Yeah.
Okay, give you another chance. Who needs a marker? Raise your hand. Erasers. All eyes up here. 5, 4, 3, 2, 1. Good, good, good. Okay. Read this out. 5, 4, 3, 2, 1, go. Okay, stop. Turn to your partners. What is the first step of a proportion problem? Go. Equal. And then read the rest of the sentence and figure out the unknown proportion. I want your answer stated in a what? In a sentence. Full sentence. Good. I see group 2 has all the units stated. That group was high. I need to see sentences on everyone's board. Our group 1 has a point and group 6 has a point. And as I'm scanning the room, I'm going to give a point for seeing units on everyone's board. Good. Good. Yep. Can you explain to him how to write this sentence? You guys all are confused? Okay. So what are we looking at? A what? What are we looking at though? Not the units, I'm saying we're looking at we're reading a what? Read the first sentence. A map. So 8 inches on the map is how many feet in real life?
28.
Okay? And make sure you discuss your answer with your board in order to get the point.
Do we have to raise our board?
I'm going to ask you to raise the board in 1 second. Do you guys get how to write this sentence up? So you would say it's inches over feet. And you said, nope, 8 inches on the map is 28 feet in the left. That's what we figured out. And raise the board up in 5, 4, 3, 2, and 1. Everyone raise your boards up. Okay, looking good. I see full sentences here. Good. Good. Very good. Very good. Good. Okay, 8 inches on the map is how many feet in real life? 28. 28 feet. Good. Quick erase. I saw full sentences from every group, and every group got it correct. So I'm giving every group 1 point. And raise your board up in 5, 4, 3, 2, and 1. Good. Group 5, raise their board first. They get the point. Next question. What is my first step? State the what?
The unit.
units on everyone's board. So we're measuring what? Centimeters over. So centimeters over. So 1 centimeter on my model car is how many feet in real life? 5.5, right? So it's 1 over. You get how to write the sentence. So it's 1 centimeter is 5.5. The known ratio is right there, right? So the question is, the model car has one okay, so where does the 4 go? 4 was, yeah. See why? Right? That is equal. Good, and I want to see your answer in a complete what?
Sentence.
Good. Good job, guys. Good, I'm seeing really complete sentences from group 2. About 30 seconds left. Finish up your thoughts. Let's see what you do. What's the ratio? 1 centimeter is 5.5 feet. It has a length of 4 what? And raise your board up in 5, 4, 3, 2, and 1. Scanning. I see complete sentences from each group. Very good. Awesome job, guys. If the model has a length of 4 centimeters, how many feet in real life? 22 feet. Good. Quick erase and raise up in 5, 4, 3, 2, and 1.
We had it first.
Good. Group 3 and 4 had it. And then everyone had a well-written sentence, so everyone gets a point. And how many class points is this worth? 2. If everyone gets it right and everyone has the sentence, I give you full credit. Okay? Next one. This one is worth how many points?
2, 3.
Good. First thing you have to do though is state what? Yeah. That's probably the most important thing, because if you do all the math out and you just can't explain it in real life. Good. I see units on everyone's board. About 30 seconds left. You should be writing your sentence. Scan around the room. Does anyone need help? Good. You should have got 33. Oh, there you go. Oh, yeah, you're good. Awesome job, guys. Seeing good work from every group. And discuss your answer with your group members in 5, 4, 3, 2, and 1. Go. And raise your board up in 5, 4, 3, 2, and 1. Raise your boards. Good, good, good. I'm seeing full sentences. Good. If the model airplane is 4.5 centimeters, how many feet in real life is that?
375.5 feet.
33.75. Why? How many times do you move back the decimal? 2 times. Good. And quick erase, raise up in 5, 4, 3, 2, and How about 2? Okay, 3.
How about 8?
You learned this good. Good enough. Next one. Hey, I'm frugal with my last one. Okay, next one. You guys need to do this in under a minute. You ready? As long as you keep everything in the correct category. Yes. The known ratio is the sentence that gives you 2 pieces of info. So where you... No, it's not 15 to 8. First write down your goals over. Okay, so your known ratio is the sentence that gives you 2 pieces of information. Which sentence gives you 2 pieces of info? Right, so that's your known ratio. You write that down first. 8% gives you the known ratio. You play how many? Good. Does that go on the top or the bottom? Good. Why does it go on the bottom? Because you're talking about games. Good. And then what goes on the top? Wait. No, just X. Because you don't know. Oh. What did I do? 15? Okay. What's that? No, I just made it up, but you can figure it out. 15 games. So times 5 times 5 equals 40. And raise your board up in 5, 4, 3, 2, and 1. Raise your boards. Okay, in 15 games, how many goals will they score? 40 goals, good. Quick erase. Good, good. Groups 5 and 4 got that? We're done. Okay. Okay. Last point's good. I don't need a sentence here, I just need to see the ratio. Yep. But how do I want the ratio? How do I want the ratio? We can go.
The ratio is simplest form of real life
I need to see it in simplest form.
It's 240 as well.
Right, but is that simplest form? Good, that's the initial ratio, right? Divided by what? What's the biggest number that can divide both? Be careful. What do you divide each one by? Can you divide 12 by 20? So you need to divide 12 by... Right, but can you divide 12 by 20 also? Oh, okay, so it's... Oh, okay, because I thought you... Okay, turn to your partners and tell them what is the ratio. Go. And raise your boards up in 5, 4, 3, 2, and 1. What is the ratio? 20 to what? 20 to 1. Okay, and challenge problem of the day. You ready? This one is... Oh, that was worth 1 point. This one is worth 4 points. What are we measuring?
Miles and stops.
Miles over hours.
Hours.
Read the whole thing carefully. Talk it out with your partners. This one's kind of tough. What's the known rate? Okay, guys. What's my known rate? Is it 320 miles by train?
Yeah.
Known rates have how many pieces of information?
It's 80 miles.
Read the second sentence. Starting now. 5, 4, 3, 2, 1, go.
The train traveled at a rate of 80 miles per hour.
Stop. Is that our known rate?
No.
How many pieces of info is a known rate? 2. Is this 2 pieces of info?
Yes.
80 miles per hour. What does per mean?
1.
Each. 1 hour. So 80 over. Our unknown rate is in the first sentence, and then how many miles does it travel?
80.
How many miles does it travel? Total. 320. What times 80 gives you 320? Or cover up the zeros. What times 80 gives you 2? Times 4. When you're in the top, do this. So it goes 320 miles in 4 hours. But it took some breaks. What is 30 minutes? Is that an hour or half an hour? It took 4 breaks of half an hour. How much time is that? Half an hour. What's another half an hour? How many would 4 half an hours be? So how many total hours did the whole trip take? That's the breaks, but how long did the train ride take? So how many total hours? Okay. Let's see if anyone can figure this out. Raise your board up in 5, 4, 3, 2, and 1. Okay. How long was the train ride? 4 hours. How long did it take in breaks? 4 half-hour breaks is 2 hours, right? The train ride was 4, the breaks were 2. You should have gotten how many total hours? 6 hours. Good. Quick erase, and erase up in 5, 4, 3, 2, and 1. Okay.
Nice.
Put away